Graph. Graph is a nonlinear data structure that consists of vertices and edges. Where is this graph data structure used? This is used whenever you want to represent relationships or connections between different objects. So these nodes in the graph, these are different objects. And what does the edges represent? Edges represent connections. So this object and this object, these are connected by this edge. So it represents that there is a connection that exists between these two objects. This sort of graphs are used for modeling networks such as, let us say, social media connections or maybe transportation systems or web links or so on. What are the components of a graph? Components of a graph. First component is something we had already seen, vertices. Vertices or nodes. So vertices are the fundamental units of a graph. They represent entities. So each of these vertices, they represent different entities in a graph. And what is the second component? Second component are the edges. So edges connect pair of vertices and they represent relationships. So we have already seen this. Edges, they can be undirected or directed. So just now we saw that these edges, these are called undirected edges. They do not have a direction. If you give a direction to them like this, then they are directed edges, which means there is a relationship from this object to the other object but not backward. Okay, that is when it is directed. One more thing is weight, but weight is optional. You may not have weight on all graphs. There may be some graphs in which you may want to put weight. So what does weight mean? Each of this edge, you can give some weight to it. So it can represent anything. It can be the value of that edge. It can be anything. So if you give, let us say, this edge is having weight 3. This is having weight 2. This is having weight 4. Like this, you can give different weights to different edges. What are the applications of these graphs when you have this graph data structure? Major application is in social networks. So in social networks, this may connect different connections between individuals. So maybe in Facebook or something, each of these will be individuals. And if they are connected to each other, then you will have one particular edge which says these two individuals are connected. So this is helpful in social networks. Another thing is in navigation systems. Let us say you want to model different cities and roads. So you may have one city here, another city here, another city here, and so on. Then if there is a direct road that is connecting one city to the other, you can have an edge there. So like this, you can model navigation systems. Similarly, you can also use it in web crawling. Maybe there are different web pages and you will have hyperlinks in pages. So in one web page, when you're reading, you may see there are some hyperlinks. So when you click this hyperlink, you'll go to some other website. So in order to show this, you can have different websites as different entities, and you can have a link that is an edge. If a hyperlink is going from one particular website to another, then you can have a directed edge which says from here you are going there. Then you can use it in maybe recommendation systems where you can say there are different users, they have different preferences, and according to the preference, you can give edges and say these users prefer these things. Similarly, there are many other applications like dependency graphs, biological networks, so on. So what we will do is, in the coming lectures, we'll go a bit more detail about different types of graphs. Then we'll also see what are the different graph traversal algorithms and so on. Okay.